Hi, Bobcats. In this section, we're going to take a look at putting numbers to the entropy change for those phase changes we looked at in the last video. So our objective is to determine delta S for these changes of state. If we're going to calculate the entropy change for a phase change, the equation that we're going to use is that delta S of the phase change is equal to delta H for that phase change divided by the temperature. For the names of these phase changes, melting is usually going to be called fusion, so we'll be given like the heat of fusion, and boiling will be called vaporization, so we'll be given the heat of vaporization. Couple usage things here in this equation. T has to be in Kelvin, and then also we may run into some weird unit conflicts. The units of S, or entropy, very standardly are joules per Kelvin, but delta H is often given as kilojoules, so we may be in a position where we want to change that to joules to have a better number to work with. And then the other trick that we'll have to do sometimes is to scale the heat, the delta H, to the amount of substance. We may be asked to find the entropy change for, say, 100 grams of material, but we're given the delta H for the phase change per mole. And so we may have to do a little bit of math there to go from moles to grams. In this example, we're given the heat of vaporization of ethanol, and we're asked to find the entropy change if 10 grams of ethanol evaporate at this temperature. And we're also given the molar mass of ethanol. So the trick here is that we're given the heat of vaporization per mole, but we're asked to find the entropy change not just for 1 mole of substance, but for 10 grams of that substance. So let's start by changing that 10 grams of ethanol into moles, and then we can use the heat of vaporization to figure out the enthalpy for that amount. So, or I'm sorry, the entropy change for that amount. So 10 grams of ethanol over 1. This is just a standard mole conversion type problem. We need to put grams of ethanol down in the bottom, and we'll put moles of ethanol up in the top. 1 mole is equivalent to the molar mass in grams, so 46.07 will go down there in the bottom. So now I'm going to take 10 and divide it by 46.07, and that's going to give me 0.217 moles of ethanol. Now, our equation was that delta S was equal to delta H divided by T, and our delta H was given as 42.3 kilojoules per mole. And our temperature is 25 degrees C, but we've got to convert that to Kelvin. So 25 plus 273 gives us 298 Kelvin. Just for reference, let me go ahead and write that up here. 25 plus 273 is equal to 298 Kelvin. And then we want to multiply that times the 0.217 moles, because if we just do that calculation straight without that last factor, that's how much we get per mole, but we don't have a whole mole, we've got 0.217 moles. All right, so I'm going to take that 0.217, because that's still showing on my calculator, and multiply it times 42.3 and divide by 298, and that gives me an answer of 0.0308, and the units on that are kilojoules per Kelvin. So now you can see why entropies often are given as joules. I'm just going to go ahead and move the decimal over 3 times to have a a little bit different sized number here. So that's equivalent to 30.8 joules per Kelvin. So if we are going to find delta S for a phase transition, delta S is going to be equal to delta H divided by the temperature of that phase transition.